Hello friends, in this video we will see one more method to convert non-deterministic finite automata into deterministic finite automata. Now this method, it is much easier and direct, and it takes less number of steps and time to get the equivalent DFA. So instead of 2 raised to q number of states and then removing the states that are not required, this method considers only those states which could be probably required. Efforts required for minimization are less. So this method directly starts with the transition diagram instead of considering all possible states, finding out delta and then transition graph. So let us start with one example. So first here I'll draw the transition diagram. Now P state for the input 0, it goes to Q as well as R. Then P state for the input 1, it goes to Q. Then Q, R, Q comma R. Then R state for the input 0, it goes to S. And for input 1, it goes to P. Then S state for the input 0, no transitions. And for input 1, it goes to P. Here P is the initial state and Q and S, these are the final state. So here M will be Q, R, S, sigma is 0, 1, delta P is the initial state and Q and S, these are the final state. We will convert this NFA into DFA. So here first we will draw the NFA from the given transition table. So here P initial state for the input 0, 1, it will go to Q, as well as for the input 0, it will go to R. Then Q state for the input 0 and 1 goes to R, as well as for 1 self loop, and this is the final state. Then R state for the input 0, it goes to S. S is also a final state. Then for input 1, it goes to P. Then S for 1, again it goes to P. So this is the NFA from the given transition table. Now let us convert this NFA into DFA. So here instead of 2 raised to q states, we will start with the initial state, that is P. Then we will find out transitions from the state P for the input 0. So P state for the input 0, it goes to Q as well as R. So here we will add new state as QR. And as this Q, it is the final state for the given NFA, this QR, it is also a final state. Then we will find out transitions from P for the input 1. Now P state for the input 1, it goes to Q. Now again this Q, it is a final state. Then we will find out transitions from QR for the input 0 and 1. That is delta Q comma 0 union delta R comma 0. Now Q state for the input 0, it goes to R, and R state for the input 0, it goes to S. So here we will add new state for the input 0 as RS. Now again this S, it is a final state for the given NFA. So this will be final state for the resultant DFA. Then we will find out transitions from QR for the input 1. Now Q for 1, it goes to QR, and R for input 1, it goes to P. So here we will add the new state as P, Q, R. Now again this PQR is the final state because of Q. Then next we will find out transitions from the state Q for the input 0 and 1. Q for 0, it goes to R, and Q for 1, it goes to QR. Then let us write the transitions from RS for 0 and 1. RS for 0, it goes to S. Now again this S, it will be the final state. Then RS for 1, it goes to P because R for 1 P and S for 1 P. Then let us find out transitions from PQR for the input 0 and 1. So here delta P comma 0 union delta Q comma 0 union delta R comma 0. So it will go to QRS. So PQR state for the input 0, it goes to QRS, and as Q and S, these are the final state, this QRS, it is also a final state. Then PQR for 1, it goes to PQR itself. Then let us find out transitions from R for the input 0 and 1. So R for 0, it goes to S, and R for 1, it goes to P. Then let us find out transitions from this S for 0 and 1. So this S for the input 0, no transitions, and S for 1, it goes to P. Then let us find out the transitions from QRS. So QRS for 0, it goes to RS, and QRS for 1, it goes to PQR. So this is the DFA from the given NFA. Now again here we need to find out if there are any equivalent state. If any equivalent states are there, then we can remove the equivalent state from the DFA. So here just you observe QR and QRS. QR and QRS. Now this QR state for the input 0, it goes to RS. Similarly QRS for the input 0, it goes to RS. Then QR state for the input 1, it goes to PQR, and QRS state for the input 1, it goes to PQR. So here QR and QRS are equivalent state. So here we can replace this QRS by QR, and we can draw the resultant DFA. So here let us draw the resultant DFA. Now here P state as it is, which is the initial state, P state For the input 0, it goes to QR. For 1, it goes to Q. Then Q for 0, it goes to R. Q for 1, it goes to QR. Then R for 0, it goes to S. R for 1, it goes to P. Then QR for 0, it goes to RS. QR for 1, it goes to PQR. Then S for 1, it goes to P. Then this RS for 0, it goes to S. And RS for 1, it goes to P. Then transitions from PQR, PQR for 1, self loop, and PQR for 0, it goes to QRS. But QRS and QR are equivalent. So this PQR state for the input 0, it will go to QR. So this is the resultant DFA for the given NFA. So once we have this transition diagram, then we can draw the transition table for the resultant DFA.